Major White and me and my classmates are here to go over lesson 25, separable equations. The basic learning objectives are threefold. We need to learn how to determine if an equation is separable. We need to solve the separable differential equations using separation of variables. And lastly, we need to apply initial conditions that are given to us in the problem into the equations. Here's an example of what a problem would look like. The main difference is we have a dy over dt and y and t in the equation. We need to solve that for a single function that we can work with and solve for anything. The three basic steps for solving the equation, once we have figured out if it's separable, is to obviously separate it, turning an implicit function to create an explicit solution, which is simply a function that we're more used to working with, a y as a function of y of x. Lastly, we simply integrate that and solve in for the equation as given, like we've done in previous lessons. To go in more detail, we have my classmate, Patrick.
Hi, I'm Patrick Romy, and here I'm going to explain separable equation. First, this is what a separable equation is. You have two variables that are on separate sides. For example, we have here is a separable equation. You have two variables that you're able to separate from each other. This is called an explicit equation. However, you can get an implicit equation where you cannot separate the two variables. As you see here, you cannot get the y separated from this x to bring it over here. And now this is how you go. This is the process of solving separable equation. First, you separate the variables. So you see here, you got the y with the y's and the x with the x's. Then you integrate. So you integrate the equation. You get the solution. So you're able to get y by itself, and that will become your general solution to solve the separable equation. Then finally, we solve. You will have an implicit equation that will be given to you, and you plug it into the general solution.
Hi, so I'm going to talk about which equations are separable because. Okay. Anyways, so a separable equations, you can't have a separable equation unless you have a first order differential equation, meaning like if it's dy dx or y prime or anything to the prime. So some of the examples I have, we're going to see if they're actually separable or not. So if we start with this first one, x squared over y squared. This is a separable equation because we can get y squared by itself with the with dy, and we can get x squared with dx. Y prime minus y minus or equals minus 4 is also separable because you can get y prime equals y minus 4. In one, like for example, this problem with y prime equals x sine of x of y or x and y, you cannot separate this equation because we have x and y both inside of the function of sine. So you wouldn't be able to get x on one side, x is on one side and y is on the other. This equation is also not separable because you can't, because of this subtraction sign, you can't separate them without getting like improper like fractions, and it's just not possible to separate. This problem right here, y prime equals y x minus y, you can separate this just because you can get y prime equals y x minus 1 by taking out the y, so you can get x's on one side and y's on the other, which makes your problem separable. So these are just the basic rules with separating equations.
Hi, I'm Andrea. So an example of a separable equation is to find the solution to the differential equation dy over dt equals 0.6 y minus 300 if y equals 75 when t equals 0 and t stands for time. So for the first part, you are going to write down your equation. So right here, dy over dt equals 0.6 y minus 300. Your second part is to separate separate the equation so you have the knowns on each side. So 1 minus y over 300 dy is equal to 0.6 dt, and 0.6 is a constant, kind of like k. So your third step is to turn your separable, or your equation that you separated, into an integration problem by pretty much adding those figures in. Okay. So your fourth step is to integrate the problem, and by integrating we got ln y minus 300 plus c for a constant equals 0.6 t plus c, another constant, because when you integrate a problem, you're always going to end up with a constant. The fifth step is to pretty much have one c on one side of the equation. So you're just going to do c2 minus c1 equals c, because a constant minus a constant equals a constant. For the sixth step, we are going to plug in the initial, which was y equals 75 when t equals 0, and to solve for c. So for step 7, you're solving for c, and c equals ln negative 225. For step 8, we're going to plug in c into the equation that we got from integrating and separating our constants. For step 9, we are solving for y by putting like terms on one side of the equation and I guess the other like terms on the other side of the equation. Okay, so for step 10, we are going to get rid of the ln's by canceling them out by adding e on both sides. And then from there, you're going to have y minus 300 over negative 225 equals e to the 0.6t. And then from there, you're just solving for y, cross multiply, and then add 300. And that pretty much sums up separable equations.